Hi, I'm Dodie Sanders with the University of Georgia Marine Extension and Georgia Sea Grant. This module is a brief introduction to the distribution of plastic in the ocean, some of its potential impacts, and things that you can do on a daily basis to alleviate plastic pollution. We will define microplastics, their sources, distribution in aquatic environments, and their potential impacts. So let's take a minute and review the definition and sources of microplastics. Microplastics are defined as plastics less than 5 millimeters in size. And where do they come from? Well, we can categorize their sources into two specific groups, the primary sources and the secondary sources. And the primary sources of microplastics are plastic particles manufactured or produced in a size range below that 5 millimeters. And primary sources can be from industrial abrasives, they can be from microbeads and personal care products, and they can be the pre-production plastic beads or pellets called nurdles. When we think about secondary sources of microplastics, these are the result of physical, chemical, and biological degradation of the larger macroplastics in the environment, discussed earlier in Module 1. There are many factors that influence where you may encounter plastics and other marine debris in aquatic systems. Here we're just going to highlight a few of them. One example is surface currents or gyres, which are created by global wind patterns, the rotation of the Earth, and the shape of ocean basins. The National Oceanic and Atmospheric Administration defines a gyre as a large system of swirling ocean currents. And this illustration of the Great Pacific Garbage Patch, an area in the North Pacific Ocean, highlights where the North Pacific subtropical and subpolar gyres converge. This is the area where marine debris accumulates. And it has been estimated that the Great Pacific Garbage Patch covers a surface area of about 1.6 million square kilometers. Seawater has a density of about 1.03 grams per cubic centimeters. Marine debris that is less dense than seawater, including plastic items like water bottles and food containers, will float. Items that are more dense than seawater, like PVC, will sink. There are some organisms, like oysters, barnacles, sea whips, they'll settle, attach as larvae, and grow on the surface of marine debris in the ocean. And we refer to this colonization as biofouling. And biofouling of marine debris makes the items heavier, which may lead them to sink below the surface of the ocean. When styrofoam cups and other plastic items floating in the ocean degrade or break down over time, the degradation or fragmentation of these items may change the density of the object and influence where they may be distributed in the water column. Leaching of additives in the plastic may also change the density of a particular object. There's still a lot we don't know about the negative impacts and the fate of plastics in the marine environment. For instance, micro and microplastics can be mistaken as food and directly ingested by marine organisms, like copepods and worms you see here. In addition, what are the impacts of the toxic chemicals associated with those plastics? There is potential that toxic chemicals may be released from plastics when they are ingested by the organisms, and that toxic chemicals may leach into the surrounding water as the plastics degrade over time. Here are just a few things, a few examples that can be done to help alleviate plastic pollution. You could reduce the amount of waste that you produce by thinking about how items you purchased are packaged. Reuse items like a reusable shopping bag. Recycle, remove marine debris from the environment during local cleanups, improve waste management, educate others about marine debris and its negative impact on the environment, and use alternatives to plastic, like glass and aluminum. Here are a couple resources for further investigations, along with additional brief modules on microplastics. Thanks for joining us on this microplastic module.